Hello everyone, welcome back to my YouTube channel. In this video, I want to explain how to solve past paper from EJU Mathematics 2018, second session, course 1, first question from the first section. So basically, this is the first question on this paper. If you want to watch the solution for the other problem on this paper, you can check link on the description box below. Or you can also check my EJU playlist if you want to find another paper for EJU preparation. Before I start, if you like this video, don't forget to share it to your friend and don't forget to subscribe my YouTube channel. Okay? In this question, let us consider the maximum value capital M. So capital M is the maximum value and the minimum value lowercase m of the quadratic function x squared minus 2 times x squared minus 2 times a plus 1x plus 2a squared. So we have a quadratic function here. And then our interval for x is from 0 until 2. And then a is a constant, and the interval for a is from 0 until 3 inclusively. The first question is, we are asked to find the coordinates of the vertex of the graph y equals to f of x. So, I need to find the vertex of this quadratic function. If you remember, we have formula to find the symmetrical axis. I usually write it down as xsim for a quadratic function. So basically this is the x coordinates of the vertex. Xsim, the formula is negative b over 2a. b is the coefficient of x, so this is our b. And then a is the coefficient of x squared, which is 1. So if I substitute b and a to this equation, I will get the symmetrical axis. So I will get negative b minus 2a plus 1 over 2a, 2 times 1. As you can see, I can cancel out the negative sign here, and then I can cancel out 2. So my x coordinate of the vertex is a plus 1. So letter a here is equals to 1. Once you got the x coordinates of the vertex, we can substitute it into the quadratic function to obtain the y coordinate of the vertex. So, to find the y coordinate of the vertex, I just substitute our x coordinate of the vertex into the quadratic function. Then, our y coordinate of vertex is equals to, I will substitute x as a plus 1 square minus 2 times a plus 1 times x, which is a plus 1, and then plus 2a squared. If you expand this expression, I'm pretty sure you will get the y coordinate of the vertex. First of all, as you can see here, this is a plus 1 squared. So a plus 1 squared minus 2 times a plus 1 squared, the answer is negative a plus 1 squared plus 2a squared. And then if I expand this, and also I will distribute the negative sign, then I will get negative a squared minus 2a minus 1 plus 2a squared. If you simplify these two expressions, 2a squared minus a squared, you will obtain a squared minus 2a minus 1. So from this answer, you can know the value of C and D, I mean B and C here. So B is equals to 2 and C is equals to 1. This is the first answer for the first question. And then for D until H, in the following sentences, choose the correct answer from among choices 0 until 9 below. So for D until H, we need to choose the correct answer here. Let us find the maximum value of capital M and the minimum value lowercase m according to the position of the axis of symmetry. Position of the axis of symmetry. We have that blah 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 and blah blah blah. Our axis of symmetry is a plus 1. This is my axis of symmetry. And then our function only hold for x between 0 until 2. So my first possibility for the position of the axis of symmetry is in this range. So for the first possibility, my axis of symmetry is in this range. So 0 less than or equals to my symmetrical axis less than 2. So 0 less than or equals to x symmetry less than 2. Since my symmetrical axis is a plus 1, I can substitute it over there. Then I will get 0 less than or equals to a plus 1 less than 2. Then negative 1 less than or equals to a less than 1. But since a is between 0 until 3, so if you find the intersection between these two conditions, then the left value here or the first value here must be equals to 0, not negative 1, because the smallest value of a is equals to 0. So if you find the intersection, you will get 0 less than or equals a less than 1. This is our first position of the symmetrical axis. So D here is 1. In this case, the maximum value and the minimum value of the function is equals to blah blah blah. Now I need to imagine the curve of the quadratic functions above. So if you imagine I have a quadratic function, you need to know, quadratic functions graph is a parabolic. And then value of x is from 0 until 2. I assume 2 is over there. And then the symmetrical axis is between 0 until 2. I do not know the exact or the precise position of the x symmetry, but the one I know that the symmetrical axis is between 0 until 2. So if I draw a parabolic or parabola in this diagram, I think my parabola should be something like this. It should be something like this. From 0 until 2. From 0 until 2. How do I know the parabola is open upward like this? It is because the coefficient of x squared is greater than 0. Since the coefficient of x squared is positive, then the parabola is open upward like this. I do not know this value of y is above the x-axis or below the x-axis. So it can be something like this. I do not know. But if you see from my illustration, we can see that the minimum value is at the symmetrical axis, and the maximum value is either when x equals 0 or x equals to 2. So from this graph, I can make a conclusion. If I want to find the minimum value, it can be at x equals to a plus 1. So m is equals to f a plus 1. You need to remember, the axis of symmetry here is a plus 1. fa plus 1, we already find fa plus 1 over here. So without any calculation, fa plus 1 is equals to a square minus 2a minus 1. A square minus 2a minus 1. This is the lower case m. So for letter F, my answer is number 5. This is number 5. And then, to find the maximum value, to find the capital M, it is either when x equals to 0 or x equals to 2. We still do not know which one will give us the greater number or the greater value. So we need to test it. F of 0 is equals to, if you substitute 0 to this function, 0, and then this x is also 0, so we can cancel out this expression. So we obtain 2a square. So if I substitute 0 to the quadratic function above, I get 0 plus 0 plus 2a square. It's equals to 2a square. And then if I substitute 2, I will obtain 2 square minus 2 times a plus 1 times 2. This x is equals to 2. 2 times negative 2 is negative 4. So negative 4a plus 1. If you expand it, you will get negative 4a minus 4. Negative 4a minus 4, and then plus 2a square plus 2a square. If you simplify it, you will obtain 4 minus 4 is cancelled out. So f of 2 is equals to 2a square minus 4a. As you can see from these two expressions, of course 2a square is greater than 2a square minus 4a, because our value of a is from 0 until 3, which is a is a positive constant. So if you put any positive constant into this expression, it will always less than 2a square. So the maximum value of our function is 2a square. This is my capital M. If you see from the choices below, the answer for letter E is number 6. Number 6. And then for our second case, the position of the axis of symmetry is outside the range of x. So our axis of symmetry is somewhere over there. So if I imagine another graph, wait a minute, something like this. this is 0, and then this is 2. My graph or my parabola is something like this. I do not know the exact or the precise location of the axis of the symmetry. So I do not know where is the axis of symmetry. But we do not need to consider this point because my value of x is only from 0 until 2. So from this illustration, you can deduce that the maximum value is when x equals to 0, and then the minimum value is when x equals to 2. Of course, you can move this graph, let's say like this, but it do not change anything. The maximum is also when x equals to 0, and then the minimum is also when x equals to 2. So don't be confused how I know this illustration. This is just an illustration. So you can draw your own illustration, but it do not change the fact that the minimum value is when x equals 0 and the maximum value is when x equals to 2. So capital M is when x equals to 0. We already find it, yeah? F of 0 is 2a squared. So letter G here is number 6. And then the lowercase m is f of 2. We also already found f of 2, which is 2a squared minus 4a. 2a squared minus 4a. So for letter H, my final answer is number 2a squared minus 4a, number 8. This is the answer for second question. Let's move to the last question. Thus, m is maximized at a equals to blah blah blah, and the value of m then is blah blah blah. Also, m is minimized at a equals blah blah blah, and the value of m then is blah blah blah. So now we just focus on value of lowercase m. Just focus on the value of lowercase m. My lowercase m is number 5 and number 8. So if I write down my lowercase m, I can express it in a piecewise function. The first function is from a equals 0 until 1. The function of m is number 5, which is a squared minus 2a minus 1. A squared minus 2a minus 1 from 0 until 1. And then from a 1 until 3, my lowercase m is function number 8, which is 2a squared minus 4a. 2a squared minus 4a. This is for 1 until 3. If I want to find the maximum and the minimum value of a, I think I can use a graphical method. So I will try to draw the graph of m. So this is m, and then this is a. Just focus on 0, 1, 2, and 3. Just focus on these 4, yeah? 1, 2, 3, 4. These 4 coordinates. When a is equals to 0, if you see from this equation, when a is equals to 0, then m is equals to negative 1. So our graph starts from these coordinates. And then when a equals to 1, If you substitute a equals to 1 here, you will get 1 minus 2 minus 1, it is minus 2. You can also substitute 1 to the second equation. You will get 2 minus 4, it's also negative 2. So when a equals to 1, m is negative 2, I assume negative 2 is over here. This is our second coordinates. And then when a is equals to 2, for a equals to 2, you can substitute it to the second equation according to this interval. If you substitute a equals to 2, you will get 2 times 2 square minus 4 times 2. You will obtain 8 minus 8, which is equals to 0. And then finally, when x equals to 3, if you substitute it over here, you will get 2 times 3 square minus 4 times 3. Then you will obtain 18 minus 12, it is equals to 6. I assume 6 is over here. So if you draw the graph of m, the graph is something like this. Once again, this is only my illustration, yeah. I do not know, and we do not need to know the exact or the precise graph of m, because by this graph you can already know that the value of m is maximized at a equals to 3, and the value of m is 6. Also, m is minimized at a equals to 1. This is the lowest position or the lowest point on this graph. So the minimized or m is minimized at a equals 1, and the value of m then is negative 2. So ln m here is negative 2. This is the answer for last question. Okay guys, that's it on this video. Thank you very much for watching this video till the end. I hope I see you guys on my next video. Bye bye.